Uh,
Then
then it goes from the eardrums to the middle of the ear.
from the eardrum, okay, after vibrating
Mhm.
the eardrum, it is going
Yes,
into the
ma'am.
ear. What are the bones that we have within the
In the middle ear, there are three bones: hammer, anvil, and syrup.
okay,
After that, it gets transmitted to the inner ear. Sound gets
okay,
transmitted to the yes, ma'am. S- then cochlea converts vibrations into electric signs,
electrical signals,
electrical signals.
okay,
Then electrical vibrations are sent to the brain by auditory nerve and
and this is how we get to know that the
yes, that
sound has heard into our ear. Okay,
yes, ma'am.
very good, excellent. That means we have revised all the things. Okay, so now let's today we have to start with the properties of the sound. Okay, so let's start with the what do you think? What could be the properties of sound?
Amplitude,
Yes, amplitude.
time
Then
period,
okay,
and frequency.
very good. Okay, so any idea what is amplitude, Ishal?
No, ma'am.
See, this is the maximum extent of the vibration that is going over a time. Okay, so this is the maximum. Ishal, just give me 1 minute here. I'm coming in just
Yes,
1 minute.
ma'am.
Yes. So this is the maximum extent of sound. Yeah, so this is maximum extent of vibrations produced by any. Ishal, are you able to see whatever I am writing onto this whiteboard?
Yes, ma'am.
I don't know why I'm not able to write on this. Extent of vibration produced by any vibrating objects, because once the object is vibrating then only the sound is produced. Okay? So produced by any vibrating object. Okay,
Yes, ma'am.
now From one more point is there, from its mean position. Okay. So if I give you an example of the bell, okay, bell is ringing only when it is vibrating to and fro. Let's say this is the mean position, this is the initial position. Okay. Initial position, after vibrating, it is coming to its original position back. Are you getting it? What is the mean position? Mean position is something from where the object is vibrating and coming to that same spot.
Mhm.
Okay. So this
Yes,
is
ma'am.
the hello.
Yes, ma'am.
Ishal, I am sharing the slides with you, dear, because I am not able to write on this whiteboard. Okay?
Yes, ma'am. Yes, ma'am.
Sharing the slides, just give me 1 minute. Are you able to see it, Ishal?
Yes, ma'am.
Okay. So Yes. So let's start with the amplitude. Okay.
Yes, ma'am.
Okay. So that is the maximum displacement, or I can say the maximum distance till which your sound wave is moving. Okay, observe this in the diagram. There is the elevation. Now what is this elevation? Something which is going up at a height is the elevation, and something which is going down is the depression. So one which is going above is the elevation, and the one which is going below this axis is the depression. Now this increased part, the distance between them is the crest. Okay, and if this wave is moving down, we have already understood that these are the mechanical longitudinal waves. So this is how the amplitude, this is how your sound wave moves along the axis. Okay, so when they are going down, okay, below this axis, so that distance is the amplitude only, and that depression is known as the trough. Okay, the crest is the elevation and trough is the depression. Okay, so the difference, if you can observe in this with this arrow, that the distance between the wave and the axis is known as the amplitude, and the distance between the two waves is known as the wavelength. Are you getting it?
Yes, ma'am.
And this amplitude is denoted by the letter A. And since we are talking about the distance and the displacement here, so this must be denoted with your meters. Okay, meters is the
Yes,
SI
ma'am.
unit for your amplitude. Similarly, if I talk, okay, let's you please write about the amplitude first and draw this diagram, then
Yes,
I'll
ma'am.
the frequency. Draw this diagram also so that you can understand what the exactly wavelength and the amplitude is.
Yes, Yes, I'm done.
Okay, now let's talk about the frequency. Okay, so frequency is the number of vibrations which is occurring in just 1 second. Okay, so if I talk about the bell only, if this the bell is moving to and fro, okay, and
Yes,
completing its one oscillation and coming back to its mean position in just 1 second, that is the frequency of that sound. Okay, so if I talk about the formula, so this is the number of oscillations upon total time, and this frequency is denoted by mu. Mu is equal to 1 upon t. Okay, so what could be, just as the amplitude has the SI unit as meter, similarly your frequency has the SI unit as hertz. Okay, understood? So if I am saying that the frequency
yes,
of
ma'am.
any sound is 20 hertz, that means 20 hertz is 20 oscillations per second. If I am saying that the frequency of my sound is 80 seconds, okay, I'm sorry. If the frequency of my sound is 80 hertz, so what I am saying, 80 oscillations in 1 second. Understood?
Yes,
Oscillation
ma'am.
meaning the number of time it is vibrating. In the case of 20 hertz also, it is the 20 times vibration in 1 second. Okay, understood? So
Yes, ma'am.
if you can see the diagram in this, so if, the difference can be notable in this. Amplitude is there. How can we say it as the amplitude? Because we have the crest also and we have the trough also. We have
Okay.
the elevation also and we have the depression also. So you would be able to understand with these diagrams that the low frequency sound is having the larger wavelength. Okay, if you have observed in this, okay, this is the
Yes, ma'am.
wavelength. Yes or no? The distance between two waves. This is the one wave, this is the second wave. Understood? So
Yes,
in the
ma'am.
case of low frequency, the distance is more. This is the more distance. Whereas if I come on to the medium frequency, so the distance is decreasing. Fine, the wavelength is decreasing.
Yes, ma'am.
Understood? But when it is going up to high frequency, so we have the more crest, okay, and we have the more trough, but reduced wavelength. Are you getting it?
Yes, ma'am.
Okay. So please write about this frequency and make the diagram also. Then we'll move on to the time period. For the time period, you can make out the formula from this only. Here we have frequency is equal to 1 upon time. Okay. So this is the time period only in which your oscillation is occurring. That is the 1 second. Fine. So we have
Okay.
1 upon t. So t will go there and your frequency will come down. So it will be 1 upon frequency as the formula for the time period. Okay. First you write about this, then we'll move on to
Yes,
that.
ma'am.
Write about the frequency. Make this diagram also for the differentiation. Is it done, Ishal?
Yes, I'm drawing the diagram. Yes, I'm done.
Okay, now let's talk about the time period. So this is the time which has been taken to complete the one oscillation or the vibration. Okay, so if you
Yes,
can see the formula, so time period is from here you can just place this t at the side of your frequency and move this frequency in the denominator. Okay, so this will be 1 upon frequency is equals to the time period. Okay, for this the unit could be the seconds. Fine.
okay.
Okay, so
Yes, ma'am.
if you can see in this diagram, amplitude is the distance between the crest and the
Yes,
axis.
ma'am.
Here, if you can see, it is the distance between the trough and the axis. Fine. So this is the amplitude. Again, this is the wavelength. Okay, the distance between two waves. Okay. Now, the time period is one which is completing this one oscillation. Fine. So it is moving from here to here. One oscillation is completed, and hence this is the time period in which it is completing one oscillation. Understood?
Okay. Yes, ma'am.
Please write about the time period also and draw the same diagram for this.
Yes, ma'am.
Is it done?
Yes, ma'am.
Okay. Now let's talk about the loudness. So what do you think? What could be the loudness?
Mm, oh, I don't know.
See, can I say it is a form of energy only? Sound is a form of energy which is traveling in the form of waves. Okay. So loudness, if there is loudness, that means more sound energy is being produced. Okay. If
Yes,
the
ma'am.
voice is low, that means less sound energy is produced. Okay. So this is the amount of sound energy. Loudness is the amount of sound energy which is reaching to the ear per second, meaning in just 1 second, the sound energy, the sound waves that are coming into ear, they are just within the 1 second. Okay.
Yes, ma'am.
Also, it depends on to the, or I can say it is directly proportional to the amplitude. Now, how it is proportional? If you can see here, the amplitude is more, here the amplitude is less. So what do you think? And we are saying that loudness is directly proportional to the amplitude. So what do you think, sound will be louder in which diagram, first or second?
Mm, second.
Yes, it will be louder in second because here the length is more. The amplitude is more as compared to the first diagram. And we know that loudness is there within the sound when the amplitude is high. Amplitude is high meaning the length is more here. Here the length is shorter. That means here the
Yes.
amplitude is lower. So your sound will be soft. Okay, it will not, it will be pleasant. Here the sound will be unpleasant. Okay, so
Yes.
the point is it is directly proportional to the square of amplitude. Now what do you mean by square? Meaning if the loudness is 1, okay, so amplitude is getting twice. Okay, it is increasing twice. If I am saying loudness is 2, so amplitude will be square of 2, that will be 4. So it is increasing by 2 times. Okay. So
Yes,
if I
ma'am.
am saying here that my loudness is more, that means my amplitude is twice. Okay. If I'm saying my
Yes, ma'am.
loudness, if my sound is soft, that means my amplitude is also low. Okay.
Yes, ma'am.
Understood? So it is the square. It is the square of the amplitude. Fine. And the
Yes, ma'am.
SI unit for measuring the loudness of the sound is decibel, dB. Okay. So
Mm,
if I say from these options, what do you think the loudness will be in which case? Loudness of sound will be in which case? From these options.
mm, average traffic. Average factory.
Yes, average factory will have more sound. It is 80 decibel, meaning what could be the impact on the amplitude? Amplitude must be high for the loudness.
Yes, ma'am.
So in the case of average factory sound, the amplitude is much higher, which is causing it to become loud. Okay, right about this loudness. Then we'll move on to the pitch in the next class. Right
Yes,
about this.
ma'am.
This is only about loudness. Don't write pitch.
Okay.
Is it done, Ishal?
Yes, I'm doing the diagram.
Okay. Is it done?
No,
Sorry.
I'm doing the fourth point. Nothing.